Today we will be presenting about LDR. Before getting into the topic, we will give a brief explanation about optoelectronics. Optoelectronics is a branch of electronics deals with light and electronic device. It includes components that emit light, transmit signal using light components. For example, LED, laser diode, photodiode, LDR. So today we will be talking about LDR. So LDR is light sensitive resistor where resistor decreases when intensity of light increases. It is also known as photoresistor. Construction of LDR. It is made up of semiconductor material like cadmium sulfide. It is used here, but we also have cadmium selenium, which will be used to detect infrared rays. Materials. These semiconductor materials have high resistance in darkness and low resistance when exposed to light. This surface is designed in zigzag pattern to increase the area of light exposure. This pattern allows LDR to sense light from different angles. Entire semiconductor material is placed in a transparent, you cannot see here, placed inside a transparent glass or plastic to avoid environmental damage. It has two terminals which is used to connect to external circuits. Working of LDR. When absence of light, the LDR will have high resistance, often in the range of 1 mega ohms, thus preventing the current flow. When the light falls on LDR, the photons strike the semiconductor material, transferring energy so that the electron from valence bond move to conduction band. As a result, more electron is available. It reduces the resistance in the LDR, so the current flows through the circuit. Here I connected a bulb in a parallel to give you about voltage divider. In darkness, only few electrons will be there. So there are very few number of free electrons, making resistance of this LDR high. So the current will pass through this bulb. So it is an application of night lamp, automated night lamp. You could see in streets where this property makes LDR useful in circuits that need to detect changes in light density, such as automatic street lights and light sensitive alarms. LDR is often connected with series to form voltage divided circuit. When the light intensity increases, the resistance of LDR decreases, so that current changing the voltage across it. This voltage change can be detected by microcontroller or any other component to trigger different actions, such as here we use to turn on or off the light. Application, we have automated street lights, light sensor, solar tracking system, which we took as project and we did. Alarm system, automated home lighting. So advantages of LDR. LDRs are low cost. It needs minimal components for functioning. It is energy efficient and it is very reliable as it works in different lighting conditions. Also, we do have disadvantage. It has slow response as compared to photodiode. It is temperature sensitive, aging effect. So, being under continuous environmental place, it often experience sunlight. So, the working of component get affected. It is not suitable for digital circuits. It is about sustainable. Sustainable development means meeting the needs of present without affecting the future. Now, Tanuj will give you a short note about the project.
So our project is about solar tracking system using Arduino with LDR. Introduction of solar tracking system. By using LDR as a light dependent resistor, we designed to improve the efficiency of solar panels automatically, adjusting the positions from the sun's movement. The system will use the LDR sensor to detect the intensity and directions to the direction of sunlight. The based on the input, we are using the Arduino controller and servo motors to rotate the solar panel using automatic sunlight. Components required. We use the LDRs, light dependent resistor, to detect the sunlight intensity and direction, and resistors used with LDRs to form the voltage divider, and servo motors to rotate the and take the solar panel, and solar panel for energy generation and tracking. Breadboards and jumper wires for circuit connections, and power supplies are using batteries. Needed for solar turbine to increase the solar panel output and maximum efficiency of the panel and maximize the power per unit area and able to grab the energy throughout the day. Dual axis tracker. So basically the solar cells will have both two axes. One is horizontal and vertical axis. We can track the sun's apparent motions exactly anywhere in the world. Working principle. We are auto tracking the control system and composers of PLC. PLC means programmable logic circuit, and sensors and signal processing units, PV cells, and electromagnetic and mechanical motion control modules and power supplies. The panel detects the sunlight sent to sensors, and sensors of this given to the PLC, programmable logic circuit, which compare it and process, and equivalent output is given so as to rotate the motor and align the panel in direction. So all the components use solar panel and LDR sensors and servo motor and Arduino Uno and breadboard. Next, LDR sensor. This is high resistance semiconductor whose resistance decreases with increasing incident light intensity and uses the light energy incident and jump to the conduction band. The conductivity of the device increases, decreases in this resistivity. This is our block diagram of our project.
Thomas would have briefly explained about the project, so we will see how it is mapped to sustainable development goals. We have 17 goals adopted by UN in 2015 to be achieved before 2030. So these goals are aimed to address present challenges. So our project is mapped as SDG 7, 9, 13, 12 and 4. 7 is affordable and clean energy as we use solar panels for efficient tracking and making use of solar energy. Industries, we use sensor and LDRs, so leading to technological innovation and supporting sustainable infrastructure. SDG 13, climate action. Instead of relying on fossil fuel, our project is aimed to get solar energy. SDG 12, responsible consumption and production. So it is aimed to reduce waste created by other source of energy. This is SDG 4, quality education. Instead of simply learning, we are applying it to practical life. That is what it given in this SDG 4. And thank you for being cooperative for entire session. Thank you.